So I'm going to go ahead and launch Alibra Design.
Great.
It should be starting up in just a moment here. And as Alibra Design loads up, it automatically loads the visual CAM product, which we now call it AlibraCAM with the latest version of. It used to be called Visual CAM for Geomagic. Prior to that, it used to be AlibraCAM, and now it's back as AlibraCAM. So the plugin automatically appears when you go into Tools and Add-on Manager. You'll see that the plugin automatically shows up right in here. It's called AlibraCAM 17. So you basically just open up your part as you would typically do. So I just pulled in your part that you had emailed us in here.
Okay.
And there's your part right there. So once you have the part loaded, you just go over to the add-ons tab and you'll notice that AlibraCAM 2017 appears right next to your add-on manager.
Okay, got it.
Click on AlibraCAM and then choose the module for milling. We have also turning modules. So in milling we offer right from 2-axis all the way up to indexed 5-axis machining, or is also known as 3+2 machining, or machining from multiple sites or orientations.
Okay.
So once you have the machining CAM interface browser loaded, you can resize this in here by just dragging it over, so you can actually view all of the contents in here.
Okay.
So you have all of these controls that'll allow you to basically change, update the UI the way you want it. So it'll allow you to also, resize the viewport. So once you save this information, it'll automatically maintain the width of the user interface, the browser that you set automatically for you. So the next time you load the same part, you don't have to go back and resize it. So that's what I.
Oh, great. Okay.
So right now we have it resized in here, and you can see that there's 2 tabs on the machining browser which is appearing in the top half, and then at the bottom half we have 3 different tabs. We have Tools, Machining Regions, and Knowledge Bases. So the Tools tab allows you to create different types of tools. You can do ball and mills, flat and mills, corner radius tools, tools for engraving, chamfer, taper. You have thread mill tools, face mill tools, dovetail. You can do fillet milling tools, lollipop cutters. You have user-defined mill, drill, center drill, reamer, tap bore, and reverse bore tools.
Now, are those all standard tools that come in a library?
Yeah, we have a library of tools for both English and metric units. You can also build your own tool library and save them. So I have a custom library currently being set and loaded in here. So you can define your own tools as well.
Great.
Now, once you have the part loaded in here, the first step you'd want to do is take a look at the part, and you want to make sure that the Z-axis is normal to the face of the direction you want to machine it from.
Okay, got it.
So in this particular case, if you notice, the Z-axis is pointing down towards the bottom, which means the Z-axis is normal to this particular face.
Right.
You see the red arrow represents a Z, so we also use the same representation in here.
Okay.
And automatically AlibraCAM inherits the same orientation that you have in Alibre for the initial orientation. But if you need to machine this part from a different orientation, so it looks like to me, it would probably make more sense to machine it from this side, because you have this kind of a recessed step, like a pocket in here. So rather than having to go back and redefine the part or redesign or do some operations to rotate the part, we have a very easy way to orient the coordinate system by going down to the Program tab, and then you can click on Machine, and this allows you to orient the coordinate system for machining. So you can establish your X, Y, Z axis orientation. In this particular case, it's just a rotation of 180 degrees on the X-axis. So I can type in 180 and then rotate about the X. You will now notice that the Z-axis is pointing normal to this face. Now I could have also used to select a surface and pick the face. It'll use the normal orientations for the surface to orient it. Or you can use these spin controls in here to establish that.
Okay. Now the XYZ at the moment, is that right at the top face? I couldn't quite tell where its default is.
Yeah, it is currently where the origin was in Alibre. So we can go ahead and pick a location of where we want to put the origin. So the machine tool setup dialog allows you to establish the XYZ orientation. Once you establish the orientation, we can then go ahead and pick the origin for it.
Okay, that'd be great if we could move that down to the bottom of the part.
Sure,
You know,
we'll do that. Now the
flattening.
next step is you establish the machining process, whether it's going to be 2, 3, 4, or 5 axis. For 2 and 3 axis, you just leave it as
Okay.
3 axis. You pick OK. So you now notice that the machine tool coordinate system is oriented. The next step we want to do is select the post processor. Now this could be done at the very end before outputting the code as well, and we have post processors for a wide range of machine tools in here. So we can select the post, either they're listed by the name of the machine tool or by the controller, and you said you have a max NC. So we have a max NC post right in here. You could use NC file extension, tab, .text, whatever is the preferred extension, you can choose that, and then pick OK to accept it.
Nice. Okay.
So I guess you can notice here I'm working my way from left to right into these steps in here. We will now define the workpiece, the stock material. With the standard configuration, you could define stock as box and cylinder stock. So box could be rectangular, or it could be defining a round stock, and this automatically establishes the minimum extent. So it looks like the part that you have is in millimeter units. It says 68 by 44 by 5 millimeter. That's the overall extents. So you define the stock. If you want to make the stock to be slightly larger, you could define it as a box, or you could even do a part box stock where you can specify an offset in X, Y, and Z to make the stock larger on each direction of the side.
Yeah, like in this part, for instance, I think we machine this out of 3/8 inch stock, you know, or whatever the equivalent metric is to that.
So we could put in 3/8 would be, we could do we could do some math in here.
Oh, okay, that's great.
So if you notice here, it tells me that it's 3/8 inch times 25.4 is 9.525, right?
Sounds right.
That's basically the stock, and you can see that the stock is being added to the part.
Okay.
So
how did it know now did it place that at the origin, or did it envelope the entire part in the initial setting?
In the initial setting, it flushes the stock to the bottom. Since the user interface shows here the bottom left corner is where it's referencing everything based on the bottom left corner of the workpiece of the part. And then it's basically adding that additional thickness above it. Now if you wanted to go back and align it, we have the ability to align the stock. We can have it top, center, or bottom. We can choose where we want to align it. So I can say I want to have it flush to the top, and then you can notice that there's extra material being left as it extrudes down.
Excellent. Okay.
So would you like to leave material on the bottom or on the top, above the?
Might as well go back to the top because that's how it would be machined. Yeah.
Okay. So you can leave the additional material on the top right there.
Yeah, perfect.
Okay, in the next step, you want to go ahead and select the 0. You could pick work 0, and you can pick where you want to place it. You can say set to stock box. You could do high as Z, mid Z, or you could do low as Z, which is the bottom.
Interesting.
And then you can pick the origin location, the southwest, what's commonly done, or you can put it in the center. So it basically puts it to the bottom center. Okay,
we typically go with center. So if we could do that, that would be great.
Yep. And then if you want to output this as your work offset number 54, G54, or 55, you can select this and then pick generate. So now you'll notice that the 000 is set to the bottom of your stock.
Great.
Now in the next step, you would want to basically go ahead and face this down, right? So you have this thickness of material that's being left above it, right? So you want to face it down. So we could do an operation called facing under 2 axis.
Okay.
And you can pick either a sketch or you can pick a bunch of face edges. You already have a sketch in Geomagic or Alibre that you created. I'm just going to use that as my part region for facing. Specify a tool in here. So if I want to use a face mill cutter, I can add a face mill tool in here. I can specify, it could be like, for example, 25 millimeter, like a 1-inch cutter. I can specify the shoulder diameter in here. I can specify the properties for the flute length. I could say it's going to be 20 millimeters, 25, 30 millimeters, like a face mill cutter right there. I can specify all the properties in here for the tool, and I can define my tool number, establish feeds and speeds. We have a built-in feeds and speeds calculator based on the material you're going to be cutting in here. You can specify the material, and also you can customize this list to add additional material types. So if this is going to be 6061, You can specify the tool diameter, number of flutes, and you can set the spindle RPM, and the system will be able to give you recommendations on the feeds and speeds. You can use this as a reference, or you can come up with your own feeds and speeds. So we now have the tool saved. I can now have this tool added to my library. The next step, sorry, go ahead.
If you did have calculated, feeds and speeds for a particular material that we've found works best for a particular cutter or something, how would you save those, or is there a place where you can do that?
Yeah, so you basically enter them in with the tool parameters.
Okay.
On the feeds and speeds tab, you save the tool, and then you can go ahead and save all of your tools to a library here by clicking on Save Tool Library. So you can have a tool library based on the material type, or if you may have a tool library based on a machine tool that you're working with.
Okay, perfect.
And now we go back in here, and you can notice that the feeds and speeds are loaded from the tool. You can set your clearance. It's set to automatic, or you could say you want to go stock max plus just probably like 5 millimeters or 4 millimeters. So it's going to clear the safe height of the stock. You specify the tolerances for roughing. You can choose a cutting pattern. You can specify the cut direction, step over, cut levels. Now, the geometry, what you're selecting here, is at the finished face of the part, which means you don't want to cut below this to face it. So I'm going to say it's at bottom.
Okay.
And then the thickness, we know it's 9.525 minus 5 millimeters, like it's 4.525.
Okay.
And you can break this up into one or multiple passes, depending on how much you want to take per cut.
Okay, got it.
Entry and exit, you can specify to have it go past in here. You can extend it.
Okay.
You can specify the same settings for exit as well.
Okay.
And all of this information I'm entering in here can be saved into a knowledge base. So when you have parts similar to these, you could just go back and add them, load them from a knowledge base. I can also apply entry and exit for each of those cutting levels. So there's 2 levels, so we are applying entry and exit for each of those levels. So there's your facing toolpath.
Okay, so if you did want to change where the tool starts?
Currently it's starting over here and then cutting, as you notice it here, since we're doing a linear cut pattern.
Okay.
So I can change the cut pattern in here. I can go from angle of cut 0 to, if I put in 90, you'll notice that it starts parallel to the y-axis. You can pretty much pick, this is called like a lace cut or a linear cut pattern. Also, we can now perform a simulation in here, and I'm going to go into the Simulate tab, and we have a simulation window. You just click on it. You basically select the operation and then pick play, and it shows your verification, material removal simulation.
Okay. And what size tool did you pick for this, by the way?
I just picked a 25 millimeter. It's kind of a 1-inch diameter cutter.
Would you mind changing that to a 1/4 inch or a 6.35?
Yeah, I can just go ahead and drag and drop this over here. Right click, regenerate. The toolpath is now generated, and that's it.
Okay. Because our little Max NC can only handle 1/4 inch tools, and we don't have any that step out, so that's typically what we. That's great.
So it's pretty easy to update tools, and now you have the toolpath generated, simulated in here. So the next step you'd want to do is basically take care of this pocket in here, right?
Okay.
And then the holes. So if you take a look at the holes, they're 2.5 millimeter in diameter. That's what it says here down at the bottom.
Yeah.
Now we want to cut this pocket, so I can do a pocket operation, 2-axis pocket machining, pocketing. Now I can drop the outer boundary that I had selected. Now I can go ahead and pick these. I'm holding the shift key in Alibre to select multiple surface edges. So I picked a chain of 4 surface edges in here, accept them to my, add them to my selection, and now I go to the tool. I can still use the same tool, same parameters for feeds and speeds and clearance, and then I would specify if I wanted to leave some wall stock, meaning stay off this edge, I can specify to leave a wall stock, or if I want to finish it, I can put the stock to 0. I can control the step over in here, and then for the cut level, the feature what you selected for pocketing is at the top face. You want the pockets to start from here, go to the depth. I can use the pick button to pick the top face and then the floor, and that'll establish the depth as a 1/4 millimeter. So the depth
Okay.
between these two. And now you can control your entry and exit. You can also set your advanced cut parameters where you can do fitting of arcs to toolpaths, and then you pick generate. So in this particular process, you're going to get a pocket toolpath for that area. So if I go into the simulate tab, each of the simulate operations can be assigned a different color, so it just makes it easier for you to see it in the simulation. So now you can notice that the pocket operation is simulated, and since you use a large cutter, it's going to leave that radius over there.
Sure.
So there was your pocket operation. Now we want to go ahead and program these slots in here, right? So
yes.
You have these slots, and you probably want to just use a cutter that can fit into the slot, right? So if I take a look at the width of the slot, this is probably 1.95 millimeter. So what size tool would you like to use for programming these slots?
Good question. It is a little bit of an odd size slot, so yeah, I'm not sure what we would normally have for that. We would probably use, I'm trying to think if we'd use an 1/8 inch cutter in there. We probably would.
Okay, so if they are 1.95, it would be smaller than an 1/8 inch, right?
Yeah,
so
we need
let me do the math here. 1.95. So that would be 0.62, a 16th.
Yeah.
So you'd want to use a 16th inch cutter. Now we actually have a method called slot machining, and we can use that for it. So we can go into 2-axis and slotting or slot machining operation. Now for the features to cut, I'm going to go select curve edge regions, and I'm going to pick the feature that's at the bottom edge. So you get a full closed loop in here because the top edge wouldn't have a closed loop around it, right?
Okay.
So you could create a sketch in Alibre for each of those, or you can go and select each of them individually if you need to. I'll just do a couple of them in here just to give you an idea how it works, but you can apply the same process. Now, one of the benefits we have in our Pro configuration is we just basically can pick one and then array the toolpath like you have a pattern in here.
Oh, okay.
You can do that in the Pro. We have the ability to do that. So we have this selected in here for the tool. I'm going to go ahead and add a new tool. It's going to be a 16th. So that would be 1.5875. Half of 3.175 divided by 2, right?
Yep.
And I can specify the flute length, shoulder length. Just make it reasonable for the tool.
Sure.
And I can save this as 1/16.
So if you specify a flute, let's say a shoulder length, or excuse me, a flute length that is less than your cutting depth, does it give you an error?
It actually marks those areas as holder collisions in the simulation.
Okay, great.
Okay, now I'm going to add a cleanup pass, and then for the cut levels, the feature what I selected is at the bottom of the pocket, or bottom of the slot, and I'm going to go from the top face right here down to this bottom edge. That's 4.75 millimeter. I can break this up into 1 millimeter passes, set my entry and exit in here, and I can also apply these for each level and then pick generate. So in this particular step, it's actually going to create a slot machining operation. You see the toolpath shows it.
Okay, sure.
Pattern. So you can always go back in here and make changes. If you want to tighten up the tolerance, you could do that. You have all of these controls in here. So there's your...
Can you explain the tolerance setting? I'm not quite following what that is.
Tolerance is used when you have splines. When you're working with splines, or when you're working with geometries that do not have a constant radius, like a ellipse or a hyperbola, or one of those geometries where it's a NURBS curve, or it could be a spline where for lines and arcs we automatically fit arcs to the toolpath, and lines should be fine. If it's a polyline, that's where the tolerance comes into effect, and you can use a tighter value like a micron or tighter to make it even more accurate. But here it's not going to make any difference because this is not a spline. This is just a series of line segments in here.
Okay.
So
What's
now,
the downside of setting that to a very high accuracy?
well, it
If you
depends
did
on
have
what your machine can handle, right? So if your machine is not capable of handling a tighter tolerance, then or number of decimal accuracy, then you might, machine may not have enough look ahead, or so you might see some kind of a jerky motion on the machine since it's not able to handle how many close points.
Okay.
So you can now notice that we were able to program these slots. Now I could have applied the same for all of them in a similar process. If you want to go back and edit these, you can just go back in here and edit the operation.
Okay.
And I can go back and add. So just hold on the shift key and you can go ahead and pick. So I'm basically selecting each of these.
Okay.
Then I'll go pick the ends of it as well. So in this particular case, these needs to be closed, right? So I'm basically selecting the sides, just making my selection a little bit faster.
Sure.
So I have these selected in here. I'm going to generate the toolpath. So now the toolpath has been generated for each of these slots on one side.
And you also said you could pattern that tool? Like let's say you had 100 slots and you don't want to select all those.
So what we could do in our Pro is, let me go back and drop this in here. I'm going to just select one of these sets in here. So what I have programmed is just for one of them right here, right? So we can identify the distance between each of these in here, right? So I can figure out in Alibre, I can go to analysis, do the measurement tool, and I can figure out the distance between these two. So that's 25.025 millimeter, right?
Yep.
And then I'm going to remove that one, and then I pick this one here. That would be 4 millimeter.
Okay.
So 25.025 and then 4 millimeters. So we have a feature called instance toolpaths. I'm going to put in 25.025 and 4. So that's the spacing between each part. And how many additional copies? I want to have one extra along the X, and then I want to have 1, 2, 3, 4, 5, 6, 7, and 8. 8 additional copies in the Y. So I pick generate. Now I'm going to drag this operation over here and then take this operation, place it underneath it. So now you'll notice that it automatically does an instance of the toolpath.
Got it.
So it does a linear, or you can do a polar. So now when you run a simulation in here, it shows each of the instances being cut.
Okay.
So
and then when it finishes each instance, where does the tool go to transit to the next one?
it goes up to the clearance plane and then goes to the next XY, and then drops down in the Z.
Okay. Now, if you want to indicate, like, let's say you're moving in that slot to machine it going clockwise versus counterclockwise within that slot, can you do that?
So basically the cut pattern is what you're talking about. So if you take a look at it here in the slotting operation, if the slot width and the tool width are exactly the same, you're going to get a single pass.
Sure.
Over here you have the direction. If the slot width is larger than the tool diameter, then it's going to do a high-speed cut pattern, like a trichordal cut pattern. You can choose between cut direction as climb versus conventional.
Okay.
So that's how you can change the cutting direction in here.
Okay.
So over here we actually program just one, and then if you notice the instance, it actually shows the tool path for each of this and shows the tool clearing. You see those Z motions that appear in yellow and red. So
Yep.
those are your yellow is the plunge, and then red is the transfer motion.
Okay.
Retract and transfer. Now we can also program these holes in here. So the holes you have is 2.5 millimeters. So we can use the same tool and then program what is called a hole profiling operation. You can do 2-axis and a hole profiling.
Ah, okay. There we go.
And I could just go ahead and pick each of these holes. Again, if you want to do the instance, you can do the instance, or you can just select each of those holes and then grab the same tool. In the cutting parameters, you can say determine the hole diameter based on the model, so it'll figure it out. And then the hole depth, I can just pick the top face and then the edge that determines the total depth. You can specify the pitch for the helix.
Okay.
And you can set also the entry and exit. And then that'll create a hole profiling operation in here.
Okay.
Creates a helical cut pattern.
Okay.
So I'm going to clear this operation out and then go ahead and run the simulation for this. You can see it basically does a helix.
Okay. Now, do you have a choice in that, what did you call that, the hole profiling?
Hole profiling, yep.
Okay. If you did not want to do a helix, if you wanted it to just step each one of those holes?
That would be just a profiling. We could do a 2D profiling in here.
Okay.
Yeah, or a pocket machining, we could do profiling.
Okay.
So I could just grab a tool, the same cutter, same type of parameters. Depth is 5 millimeters.
Okay.
Let's go in steps of 1 millimeter each, and basically it'll do a constant
Got it. Okay.
Z level each cut. So you can notice each of those are, if you run a verification, so basically steps down.
Perfect.
Now, one of the benefits of Pro is also you can program this from additional sites. So if you have features that needs to be machined from additional sites, you could still do it.
Right.
Flip it over. So you can create additional setups. You go to setup, and then you can create a new setup to orient the coordinate system to a different face and machine it. So the Pro also includes that. Pro also includes advanced 3-axis operations like re-roughing, remachining, advanced 3D finishing techniques. And if you also have a rotary table on the machine, your 4-axis is included with the Pro.
Okay. Now, if you wanted to add tooling holes to a part, even if you don't have the drawn in Alibre, is that something you could do here, or would you need to add that in Alibre first?
When you say tooling holes, you want to basically insert some holes into the part?
Yeah, like let's say you did have to machine top and bottom and you wanted 4 reference holes so that you could locate it on, say Delta.
Like a registration pin, basically.
Yeah, yeah.
So one of the ways you could do it is you can go ahead and create a new sketch in here in Alibre, and then I could use a rectangle. Maybe I'll just go pick a center, and I'll just throw in a rectangle right there.
Okay.
We can also dimension it. You could say it's going to be 40 by 30 millimeter. I can display the sketch. Okay, so once you have the sketch drawn in here, you can go ahead and you have the sketch created right there, right? So we have this, oh, did I not create the sketch? Okay, I may have not created the sketch right there. So I may have exited before the sketch was created. So let me go back in here, activate a sketch. I'll put in a rectangle. I'll dimension it if you need to. Okay, that's going to be, I'll just put in 80 millimeters.
Okay.
And I'll create this. I'll put in maybe 50 millimeters.
Okay.
Okay, so now we have the sketch drawn, and I can go ahead and activate a new sketch in here. And maybe you can just insert points, or you can even put in circles. You don't really have to make it a 3D model.
Okay.
You can specify a circle, and you can use dimensioning for it. You can say what is the dimension, 2 millimeters or 2.5 millimeters. You can also add relationships in here, how far it needs to be, right?
Sure.
From this to, you can add dimensioning between these two, and then you can also specify constraints in here. And once you have those created, I'm just going to go ahead and add a few circles in here. So we have those circles created. Now all I got to do is program a toolpath for it. So those could be programmed as a profiling or a whole profiling operation.
Okay.
However you want to do it. Or you can even do a drilling operation. Just pick those
Okay.
holes and use a hole machining and drilling. And I have the select. I can even use an end mill for drilling it, or I can use a drill bit and specify the depth you want to cut. It's going to be 5 millimeters, or if it's going to be 9.525 from the 0 that we've defined. And you can do a standard drill, or you can even do a peck drill, specify a step increment and generate. So that'll get you a drill operation.
Okay.
And you can specify where you want the cuts to start at. So that'll create a drill operation for us.
Okay, and then if you want to set, this is maybe a little trivial, but on that, say, pecking operation, if you want to change the feed rate for the peck, where is that information in there?
So what we do on a peck drilling is we output a CAN cycle for drilling. So typically it outputs a G83, and then it outputs a cycle feed rate. That feed rate is over here. So when you post it, it'll output a peck drill cycle. So when I do a post, you see that there's a G83.
Okay.
The Q, and then the F is the feed rate that you're seeing right here. So the controller interprets this peck drilling cycle.
Okay. So it pulls that default value in?
Yeah, it takes this value, and the drill cycle can only accept a single value for the feed rate. And the cycle is interpreted by the max NC control or Haas or whatever the machine control is.
Okay. So could you save custom peck drill settings?
When you say custom peck drill settings, if you want to...
For instance, one thing that's really critical to us is we do a lot of drilling and a lot of peck cycles. Let's say we've got a part with 1,000 holes in it. We tailor each one of those feed rates and that those values for the the Q value and that feed rate you've got highlighted there. We tailor that pretty specifically to each part.
Yeah, you can save them into like a knowledge base. So you can have this saved to a knowledge base where this could be, you can have a drill, peck drill, tap, maybe a sequence of them, have them saved to a knowledge base for, call it, this is for material, 6061, and you can have everything saved. So you just have to load the library, pick the holes for other projects. So you can create like a template of operations.
Okay. All right. Then I've got a really complicated question for you. We make our own, we write our own program for pecking sometimes when we don't like the canned cycle. And so we just go into the G code and edit it ourselves. Is there any way to have a custom canned cycle in here like a peck cycle, but it's one that's our own?
Okay, is it similar to a G83 where it expects
it's very similar, but we customize it sometimes.
So if you notice under drill types, we have user-defined drill cycles.
Okay, there we go.
When I select user-defined, I can specify these parameters. This could be a peck or without a peck.
Okay.
And in the post processor, we have a customizable post, and I can go down to user-defined drill, and I can define the cycle code. This could be G83.1.
Okay. Yes.
I define the macro. So typically on a deep drill cycle, we output X, Y, Z, and then R, F, and Q, or RQF. So you can access all of the macros or variables in the post by performing a right-click in any one of these fields, and then it'll give you all of the available variable types that you can use in the post.
Okay, perfect.
If you just select them, it'll insert the macro in there.
Okay.
And then you can save up the post. You can also rename the post to custom name it. So it'll always be available to you.
That's great.
Any other questions I can help you,
No,
Eric?
I think that covers it pretty well.